Zig 0.15.1 is out, and it's a pretty big one. So we're talking about massive speed improvements, some painful but necessary breaking changes, and a complete overhaul to Zig's IO system that we're referring to as Writergate. So if you've ever been curious about where Zig is heading, this release should give us a pretty clear picture. Let's break it all down. I've got the release notes up here. It is in dark mode. I am sorry. We're going to flip it over to light mode. So if you're in the basement with your lights off, being a basement dweller or whatever's going on with all the people who demand dark mode, we're going to flip it. Close your eyes. 3, 2, 1. Okay. I think... The heck? Try that again. I think that this will be easier to read in light mode. So we're going to go through that. Easier for you, easier for me. We'll even make it a little bigger. Okay, so there's a lot going on. So we have 5 months of work, changes from 162 different contributors, spread amongst 647 commits. Quite a bit of work. Some of the highlights include faster debug compilation with Zig's x86 backend, now selected by default, and work in progress for the Arch64 backend, hot on its heels. They talk about Writergate. They link to it here. There's actually a really good talk about Writergate from, the conference that Tiger Beetle put on a few weeks back. Andrew Kelly has a talk called Don't Forget to Flush. I think I can put a link to that somewhere up here. So I will do that post-upload. So keep an eye out for that. I would recommend checking it out. It's a pretty good talk. There's also a slew of language changes and standard library cuts that rock the boat with tidal waves of breaking API changes, the harbinger of async await resurrection, the last bastion defending language stabilization. Very vivid picture. Big fan of this. Okay, but let's actually break it down so it's, comprehensive. So there's a table of contents here. We're going to go through some of the stuff. I've read through this once and a half at this point. I might skim over a couple of things, but we'll try to make sure that we cover the things that I feel are important for you to know. So if you're unfamiliar with the tier system, so Zig has a tier system that is the level of support for various targets. There's 4 different tiers. Tier 1's the highest. So the goal for tier 1 is right here, 0 disabled tests. And this will become a requirement for post 1.0 releases. We're not here yet. Just keep that in mind. So if you are unfamiliar with this, this might be good to familiarize yourself with at some point. Since we're not at 1.0, it doesn't really matter too much. The key thing here is that tier 1 is generally getting more eyes than tier 2, which is more than tier 3, which is getting more than tier 4. Just something to be aware of. There's this really nice support table, so you can see what is being supported here. So there's your targets on the left. The tier might make this easier to see as well. And then there are these indicators that indicate whether they have full support, no support, or partial support. So yeah, you can see through there as well. We're going to skim through this table. That's something you could look through on your own time. I don't think there's anything particularly earth-shattering in the table that you wouldn't be aware of at this point. So OS requirements for the compiler and for Zig itself, there's some OS requirements. I can't imagine too many people are trying to do anything outside of these, but if you are, update your OSs. You should probably do that sooner rather than later, just for security purposes too. And if for some reason you don't want to upgrade to Windows 11, come join us on any of these. Some information about additional platforms that have varying level of support. There's some interesting stuff here. So like watchOS being an interesting one, visionOS being another interesting one, CUDA. So just a couple of things that you might want to keep an eye on if you're interested in this space, like building tvOS apps in Zig, something to keep an eye on. Okay. Language changes. There's some minor changes. Packed union fields are no longer allowed to specify an align attribute matching the existing behavior of packed structs. So packed unions will now behave like packed structs. It previously did not affect the alignment of fields, so it was kind of redundant and maybe misleading. Using namespace has been removed. This keyword added distance between the expected definition of a declaration and its actual definition. Without it, discovering a declaration's definition site is incredibly simple. That is totally true. Find the definition of the namespace you're looking in, find the identifier, and then you're good to go. With using namespace, however, the programmer can be led on a wild goose chase through different types of files. I have not actually used using namespace before, but I could see how that would cause a problem. It's difficult for humans. It's problematic for tooling such as Autodoc, all sorts of things. So I don't think many people are using it. I agree with namespacing is good, actually. And yeah, they've removed it. There's a use case for conditional inclusion. So using namespace can be used to conditionally include a declaration as follows. Sorry, I'm misreading this for a second. This has been removed, but it's still here. Oh, no, sorry. This is a use case I think that they do value, but are providing another alternative here. The solution here is pretty simple. Usually you can just include a declaration unconditionally. Zig's lazy compilation means that it will not be analyzed unless referenced, so there's no problem. Occasionally, this is not a good solution as it lacks safety. Perhaps analyzing foo will always work, but will only give a meaningful result if have foo is true, and it would be a bug to use it in any other case. In such cases, the declaration can be conditionally made a compile error, like so. This does break feature detection with has declaration. If feature detection is needed, a better approach, less prone to typos and bit rotting, is to conditionally initialize the declaration to some sentinel value, which can be detected. A good choice for the a good choice is often the void value. So this one. There's an example of doing the same feature detection type thing here, so you can see how it's being used here. Nothing crazy. I can't imagine too many people are using namespace, so I don't imagine too many people will see that and be like, wow, that's going to change everything. Another example is implementation switching. So yeah, maybe it is actually then. So in the case of, you can use it to select multiple implementations of a declaration at comp time. So for example, right here, if it's Windows, this stuff. If it's not Windows, this stuff. So, geez, a little jaded maybe. The alternative to this is simpler and results in better code. So you can see here's how this is handled without using namespace. And then mixins being another big one. So an example of essentially building a mixin, and then how you would do that with, yeah, interesting. Sorry, I got a little distracted there, but yeah, so you'd essentially build a mixin like this, and then you would pub using namespace, and then throw the mixin in here. The alternative for this is based on the key observation made above. Namespacing is actually good. Yeah, I agree. Same logic can be applied to mixins. So then here's an example of how to do this if you were working with mixins without using namespace. So just like before, there you go. Okay, kind of, this is actually really small, but actually really big at the same time. So async and await keywords have been removed. Also removed at frame size. While suspend, resume, and other machinery might remain depending on the proposal stackless coroutines as low-level primitives. This is probably a very interesting proposal to read through if you haven't yet. Neither have I, full disclosure. So I don't know if it is interesting, but it seems like it would be. It is settled that there will not be async await keywords in the language. Instead, they will be in the standard library as a part of the IO interface. Loris and I talked about this on our interview 3 weeks ago now. So if you haven't seen that yet and you want to learn more, I'll put that video somehow, somewhere linked in this video. Worst case scenario, it'll be in the description. Yeah, so why is this big and why is this small? These keywords are being removed. They weren't really doing anything due to async and await being removed a while back. But this is essentially groundwork to make sure that the new IO interface and all of the fun async await async IO, work that is being done will be able to be completed in the future version of Zig. Okay, switch on non-exhaustive enums. Switching on non-exhaustive enums now allows mixing explicit tags with the underscore prong, which represents all the unnamed values. So there's an example here. So if you wanted to do, you have enums that support multiple cases, you could use the underscore to make sure that you're covering that case, even with non-exhaustive enums. It is now allowed to have both else and an underscore. So you can see there's an enum here. That enum has an underscore as one of its properties. And then name tags would go here. So if you are supporting A, B, C, like so, but your switch only has A and C, then this else would capture your B. And then if you have anything that's not named, like an unnamed tag, it would go here. My impression is maybe don't do this. Like, it's nice that this is here. If you find a use case where it really makes sense, I wouldn't shoehorn this into your code. I would just add B explicitly and try to make it as clear as possible. This is without these comments, this could be a little hard to follow. So just something to be aware of. Allow more operators on bool vectors. Allow binary not, binary and, binary or, binary XOR, and Boolean not operators on vectors of Booleans. Okay, cool. Sounds useful. Inline assembly, typed clobbers. Sheesh. I actually know almost nothing about this outside of what I've read so far. So until now, these were stringly typed. It's kind of obvious when you think about it. So they have some examples here. And then here is that new output, I believe. So yeah, inline assembly is going to be typed properly, I assume now. Actually not seeing a ton of difference here outside of this last line, and maybe it is just that last line. Really nice little piece to this, though. If you're doing this to auto upgrade, run Zig format, and it'll take care of it for you. That is really, really nice. Okay, allow pointer cast single item pointer to a slice. This is essentially an extension of the 0.14 change that allowed pointer cast to change the length of a slice. It can now also cast from a single item pointer to any slice, returning a slice which refers to the same number of bytes as the operand. Here's an example of that here. You can see we're pointer casting here, single item pointer right here, being coerced to a slice here. Note that in a future release, it is planned to move this functionality from pointer cast to a new built-in memcast built-in, with the intention that the latter is a safer built-in, which helps avoid unintentional out-of-bounds memory access. For more information, see issue 23935. New rules for arithmetic on undefined. I think the key thing here is that we... so here's a compile error. Simply avoid this operation. And the reason that this is a compile error is because B is essentially going to be undefined in this case. Nice to catch that at compile time, so extra good there. And then, yeah, you can see what that looks like whenever you were to try to compile your Zig program. Error on lossy coercion from int to float. This is kind of a big one. So Zig will now error on lossy integer to float coercions and no more silently dropping precision, which seems very important. Okay. Now, the real story in this release is what's happening with the standard library. This part's been nicknamed Writergate because Zig's entire I/O system has been reworked. And yes, it is a breaking change. So there's some uncategorized changes here. You can read through those if you want. I don't think anything is particularly interesting. If you're doing file stuff, they've removed write file options, write file all, and write file all unseekable in favor of the file writer. That maybe is a little more relevant. Just some stuff to be aware of here. Okay, Writergate. So here's what's changed. The old generic readers and writers are gone. In their place, we now have a new standard I/O reader and standard I/O writer. These are interfaces. These new interfaces are smarter. They keep the buffer inside the interface, which means hot paths run without virtual calls, and you only pay the cost when the buffer fills up. I think that's the main thing. Here's a link to that talk that I was talking about. Don't forget to flush. Highly recommend checking it out if you would like to learn more. These changes are extremely breaking, but more or less viewed as this is the route that Zig needs to go. Please come along for the ride. It'll be worth it. Some more information as to like why and what the issues were. The past is past. This is probably good to read so you have an understanding of why this is, especially if you ever want to build your own language. You can stand on the shoulders of giants and maybe not make the same, not that it was a mistake, but it wasn't the implementation that we ultimately needed going forward. And I'm sure it was fine at the time, but sorry, I'm not trying to bash Zig or Andrew or anyone. I just, yeah. Okay, besides that, so there's an adapter API. So if you have an old stream and you need a new one, you can use adapt to new API like this. I really don't like that method name, but it is what it is. So there's a writer here, call adapt to new API, bada bing, and now you have that adapter, exposing the new interface, and then you can do all the things you need to do. My suggestion would be maybe try to avoid using this. And instead, if you can rewrite the pieces that need to be rewritten, I would rewrite them. Otherwise, I mean, the adapter's here, so use it if you feel it would help you. The new standard IO and writer, standard reader APIs. These are ring buffers. They have a bunch of new APIs that are more convenient, perform better, and are not generic. For instance, look at how reading until a delimiter works now. So there's really, really straightforward code for reading until a delimiter. Strings also feature some unique concepts compared to other languages' stream implementations. So the concept of discarding when reading also allows efficiently ignoring data. For instance, a decompression stream, when asked to discard a large amount of data, can skip decompression of entire frames. Concept of splatting when writing allows a logical memset operation to pass through I/O pipelines without actually doing any memory copying, which is extra nice there. Sending a file when writing, this allows the I/O pipeline to do direct FD to FD copying when the operating system supports it. The stream user provides the buffer, but the stream implementation decides the minimum buffer size. This effectively moves state from the stream implementation into the user's buffer. Okay, so with these changes, there are some things that cascade into a lot of APIs. So standard FS file reader and standard FS file writer are now the way moving forward. Things like standard IO get standard out.writer.print, so like this. They've been updated, so please use buffering and don't forget to flush. There's your flush. Don't forget it. Some types like counting writer. Yeah, down here. Okay. Some types like counting writer and buffer writer are just gone. You don't need them anymore. They don't exist because of the current implementation for our writers. This one's kind of interesting. So F required to call format methods. So you can see here, you can turn on F reference trace to help you find all the format string breakage. So if you try to do this, for example, ambiguous format string, specify F to call format method, or any to skip it. And then here's an example of the fix right here. The motivation for this is eliminating two different footguns, introducing a format method to struct to cause a bug if there was formatting code somewhere that prints with curly braces and then starts rendering differently, removing a format method to a struct caused by a bug if there was formatting code somewhere that prints two curly braces and is now changed without notice. That makes sense. Now introducing a format method will cause compile errors at all curly brace sites. In the future, it will have no effect. Format methods can also no longer take format strings or options. So there's a little bit of information on that. What else? Unicode handling has been stripped out of formatting. On top of that, this one's actually kind of neat. We have some new formatted printing specifiers. So T is shorthand for tag name and error name. This is super nice. Not having to use these and coerce them to a string, and then use the string here. D and other integer printing can be used with custom types, which calls format number. And then B64 output string as standard base 64. That also seems really nice. With these changes, there's no longer an incentive to hand roll next and previous pointers. A little bit less bloat too. So migration guide on essentially linked lists. This would go to this. And then you would use field parent pointer to get from node to data. Okay, we are making good progress. Not too much further. But speaking of progress, standard progress now supports progress bar escape codes. Turns out there are escape codes for sending progress status to the terminal. It integrates with --watch in the build system to set error state when failures occur and clear it when they're fixed, also to clear progress when waiting for user input. Standard progress gains a set status function and the following enum. So there's an example of the enum with statuses such as working, success, failure, and failure working. The HTTP client and server, these APIs and implementations have been completely reworked. Server no longer depends on standard.net and instead only depends on standard IO reader and standard IO writer. That is a little wild to me, but in theory, a server doesn't necessarily need to know about networking. It should just know reading and writing, which makes sense. It also has all the arbitrary limitations removed. For instance, there's no longer a limit on how many headers can be sent. No limit. Give it the buffer. let it do its thing. So here's an example of taking this and converting it to 0.15.1. A little bit more code, but also hopefully a little more clear. Server and client both share standard HTTP reader and standard HTTP body writer, which again, only depends on IO streams and not networking. The information on the client upgrade. So if you're using an HTTP client, which I am in one of my projects, I will need to do this. Here's what you might have currently in your code base. And here's what you would update it to. We also have TLS client support. So standard crypto TLS client no longer depends on standard.net or standard.fs. Instead, you guessed it, it only depends on standard IO reader and standard IO writer. Slight tangent here for a minute. So if you come from a Go background, the reader and writer interfaces are like, they're all over the place. And it is essentially this like really nice abstraction point for doing a lot of things in Go. So being able to take one file and read it in and convert it to another file, you would chain together reader and writer implementations. But you could write that same pipeline and maybe instead of files, now you're taking in HTTP streams. And maybe now instead of HTTP streams, you're taking in something else that you would read and write. You've got options. The point I'm getting at here is like, I like what Zig is doing here, taking this reader and writer approach. I've seen it work really well in Go. And I think if Zig does something similar, ultimately, it'll probably work really well for Zig as well. Okay. Array lists. So this one's going to bite me. Make unmanaged the default. I tend to overmanage things. So you can see here, standard array list now becomes standard array underscore list dot managed. And then standard array list aligned becomes standard array list aligned manage. Warning, these will both eventually be removed entirely. Having an extra field is more complicated than not having an extra field. So not having it is the null hypothesis. What pattern does having an allocator field allow that not having one doesn't? The English is, what pattern does having an allocator field allow that not having one doesn't? Nope, never mind. The English is fine. My cadence was off. So yeah, basically, do we get anything by having an allocator that wouldn't be supported by not having one? This helps you avoid accidentally using the wrong allocator, and it's convenience when you need to pass an allocator also. But there are downsides. Worse method function signatures in the face of reservations, inability to statically initialize, extra memory storage cost, particularly for nested containers. The reasoning goes like this. The upsides are not worth the downsides. Also, given that the correct allocator is always handy and incorrect use can be trivially safety checked, the simplicity of only having one implementation is quite valuable compared to the convenience that is gained by having a second implementation. That's fair. That is fair. In practice, this has not been a controversial change with experienced Zig users. Yeah, okay, that seems reasonable. Ring buffers. There are too many ring buffer implementations in the standard library. Find out more at this link. Standard FIFO, linear FIFO is removed due to being poorly designed. This data structure was unnecessarily generic due to accepting a comp time enum parameter that determined whether its buffer was heap allocated with an allocator parameter passed in as an externally owned slice or stored in the struct itself. Wow, so many options. Each of these different buffer management strategies describes a fundamentally different data structure. I agree. Furthermore, most of the real-world use cases are subsumed by, you guessed it, standard IO writer, standard IO reader, which are both ring buffers. Similarly, standard ring buffer is removed since it was only used by the ZSTD implementation, which has been upgraded to use the new standard IO writer and standard IO reader API. There was also standard compressed flate circular buffer, which was internal to the Flate implementation, also now deleted. There was also one each in HTTP client and server, again, deleted in favor of standard IO writer, standard IO reader. If you haven't got it yet, your key takeaway should be the words standard IO writer and standard IO reader. Even with all 5 of these deletions, these things pop up like a whack-a-mole. Here's some more ring buffers that have been spotted. Jokes aside, there will likely be room for a general purpose, reusable ring buffer implementation in the standard library. However, first ask yourself if what you really need is the standard IO writer or the standard IO reader. Okay, bounded arrays have been removed. It was popular due to being trivially copyable. However, such convenience comes at a cost. You can read through this if this is relevant for you. Here's what you maybe had. Here's how you would have the same thing in Zig 0.15.1. As an aside, I really like that they are doing these like little translation pieces. So saying, hey, this is what your code looks like. This is what it's going to look like now. That's nice. There are a load of deletions and deprecations. I'm not going to go through all of them. Here's the key thing. Most of these are being replaced by standard IO writer and standard IO reader. Here you go. Here's your list. Okay, build system. Let's talk through these. We just have a couple more things to get through. So the short and sweet for the build system is a few notable things. The deprecated implicit root module has been removed. File system watching has been added for Mac OS, which I'm excited for. I don't know if you can tell from this video, but I am on Mac OS. Actually, you probably can't. The way this is cropped is a little weird. This is nice. So yeah, you can throw the watch flag in Zig build and it'll, auto build whenever there are changes. So if you were avoiding watch in previous Zig versions due to the Mac OS bug, you can now use it safely. Woohoo! Besides that, the build tools web interface and time reporting also got some polish. So essentially better visibility into what your builds are doing and better integration across all platforms. So there's some stuff that you can see here. Here's that web-based build system that we were talking about. It's a relatively advanced feature, but can be useful for determining parts of your code which are needlessly slowing down compilation by opening the declarations table and viewing the first few rows. I actually haven't looked through this before. This might be a fun thing to look at in maybe another video and see what information we can glean from this. Okay, compiler. Yeah, so a couple huge upgrades for the compiler. So there's incremental compilation that is now supported across the box. So hopefully you will be able to enjoy incremental compilation. Code generation is threaded, meaning faster parallel builds. You can configure UBSan, UBSan. I'm not sure what the pronunciation for that is. On a module level. Actually, we'll get to that in just a second. There's an x86 backend that is the default now in debug mode, except on NetBSD, OpenBSD, and Windows. Working on an Arch64 backend, incremental compilation, threaded codegen, like I mentioned. Yeah, this one. I actually don't know how this is pronounced. UBSan. But you can configure UBSan mode at the module level. Tests can be compiled into object files, giving you more flexibility. The flow for Zig and Knit has been improved. This is kind of nice. So there's a new template for creating projects. Old template included code from generating a static library of a Zig module, which caused some newcomers to mistakenly think that this is the preferred way of sharing reusable Zig code. New template offers boilerplate for creating a Zig module and an executable. Should cover most use cases and show how to split logic between a reusable module and the application. Yeah, I'd give that a shot and try that out and see what your thoughts are. I will probably start a new Zig project soon to try that out and see what my thoughts are as well. You can also pass -m or -minimal to Zig init to generate a minimalistic template. So if you want something much smaller, you kind of already know what you're doing. You're familiar with the Zig build system. This might be an easier way to get started. I'm not sure how I missed this somewhere, but the toolchain got bumped up to LLVM 20. There's better support for dynamically linked FreeBSD libc when cross-compiling. Yeah, I'm not sure where I missed that at, but that is in my notes. Did we skim through that? No, it's down below. Okay, sorry, I have it in the wrong section in my notes. Okay, we'll get to that in just a second then. There are small changes in the linker and the fuzzer, but there are still known bugs, regressions, and even in some cases miscompilations. So, just be aware of that. We know that Zig's not 1.0. It's not pretending to be 1.0. I think it's a fantastic language, and I would recommend starting sooner rather than later with Zig if you plan to pick it up eventually, because you will have a wonderful time. But there are some sharp edges. Okay, yeah, here's the LLMV20 stuff. Okay, I'm not sure how I missed that. So this release of Zig upgrades LLVM to LLVM 20.1.8. This covers Clang and Zig CC, Zig C++, lib C++, lib C++ ABI, lib unwind, lib tson as well. Now supports using LLVM's SPIR-V backend. What else? Yeah, I mean, you can read through this if this is particularly relevant to you. Basically, dependency updates for LLVM, which give us some nice things. Let's see. The two major themes of the 0.16 release cycle will be Async IO and the Arch 64 backend. This one's going to be wild. Like, this will be... I don't know if they have any other big shifts planned for the language anytime soon. Based off the proposals I've seen and the stuff I've read, this is going to be the biggest shift we will have in quite a while. However, the standard IO reader and writer stuff that I've talked about so much already is going to make this less painful to implement when 0.16 comes around. So if you're on 0.14, like I am with several of my projects, I would strongly recommend upgrading to 0.15.1. So when 0.16.0 hits, you are ready to roll with Async IO. Some upcoming milestones: introducing IO as an interface, Arch 64 backend, linker compilation or linker implementations, integrated fuzzer to be competitive with AFL and other state-of-the-art fuzzers. IO as an interface. Moving forward, Zig will rearrange all of its file system networking, timer, synchronization, and pretty much anything that can block into a new standard IO interface. I like this. I think this is a good move. All code that performs IO will need to access an IO instance, similar to how all code that allocates memory needs access to an allocator instance. It is very, very similar. Again, if you're unfamiliar with that, check out the interview that I did with Loris Crow, the VP of Community at the Zig Software Foundation. He talked about it a ton. So there are examples, and we refer to some of his blog posts that he's done, and plenty of information on that if you're curious what that'll look like. Tons of new contributors, so thank you everyone who contributed. Thank you to the sponsors. Yeah. So I think last but not least is just kind of community feedback. So just from what I've seen, it's been pretty interesting. So I saw that one user has tested their code base and has seen builds drop about 20 seconds in Zig 14 down to about 7 seconds in a master build that essentially equates to 0.15.1. So it wasn't 0.15.1, but it was a version that was pretty close. And that's about a 66% improvement just by upgrading the compiler, which is pretty nice. As for Writergate, some people admit that it's painful. The consensus seems to be that it is necessary. The good news is that this was the big breaking wave, and hopefully we'll have smoother sailing from here on out. So that's Zig 0.15.1. So faster builds, leaner language, completely overhauled IO system, and a compiler that's getting more and more stable every release. So what do you think about these changes? Are you as excited about the IO overhaul as I am, or dreading the refactoring work? Let me know down in the comments below. And if you found this breakdown useful, don't forget to like and subscribe. I'll keep covering Zig updates as they land. Thank you for watching, and I will see you next time.